Hello and welcome back. Let's look at this example 3. In the example 3, they asked us to form the ODE, the ordinary differential equation of the equation y is equals to exponential into c1 sine x plus c2 cosine x. So where c1 and c2 are arbitrary constants. So you have two arbitrary constants. So how many times will you differentiate? 2 times. So you are going to form, you are expecting an ODE of what? Order 2. So let's begin the solving solution. So you are going to perform your first derivative, right? So you perform your first derivative, y prime, that's the first derivative, y prime will be equal to what? You know, this is product of this is the product of exponential and the sum of sine and cosine functions, right? So we are going to use what? Product rule. So we differentiate exponential and keep this. So if you differentiate exponential x, what will you get? Exponential x. So if you differentiate exponential x, you still get your exponential x into c1 sine x plus c2 cosine what? X. So this is what you get. What do you do next? You put what? Plus, right? Then you hold exponential and differentiate this bracket, right? Differentiate what you have inside this bracket. So I'm holding my exponential x and I'm differentiating what I have inside the bracket. If you differentiate sine, you have positive cosine, c1 cos x, c1 cosine of x plus, okay, let's know what we'll get here. If you differentiate cosine, you get what? Negative sine. So you have negative c2 sine x. So this is what you get, right? But what do you notice from this but what do you notice from this thing we did here? The first result is exactly your original equation. So I'm going to write the first result in terms of your what? Original equation, so that we reduce the bulkiness, because we know we are going to differentiate again, right? To reduce the bulkiness of it. So this implies that y prime will be equal to, from here, the first thing we have is exactly my y, so I'll write it as y plus, then the second result we got, exponential x into c1 cos x minus c2 sine x, right? Now we have reduced the bulkiness of the expression. We are going to differentiate this thing. We are going to differentiate this thing again. Let's move this y to the right, and let's move this y to the right. This implies y prime, if you move positive y to the right, you have negative y, then equal to exponential x into c1 cosine of x minus c2 sine x. So this is what you have. So, but you know you have to differentiate again, since you have two arbitrary constants. So you are going to differentiate this expression again. Differentiate this expression again. So we are going to differentiate each. If you differentiate this, we are going to differentiate this implicitly, right? Because this y prime is a function of what? X, and y2 is a function of what? X. Your dependence variable is a function of what? Independent variable. So if you are differentiating this again, so you are differentiating this y prime again, you get what? Y prime prime, right? So this implies, okay, we are done with this one, right? Differentiating the second time, we get if you differentiate this y prime the second time, you have y prime prime, right? Minus, differentiate y you get what? Y prime equal to differentiate this expression you have at your right hand side using what? Product rule. Differentiate exponential, you still have exponential. You differentiate exponential and keep this thing. You do exponential, you have your exponential back. We are now keeping C1 cosine of x minus C2 sine of x. What's the next thing? You put plus, then you keep exponential, differentiate the expression you have inside the bracket. Differentiate cosine, you have what? Negative sign. So you have negative C1 sine of x. Then if you differentiate sine, you have what? Positive cosine. But you have negative sign before, so you have negative C2 cosine of x. So but we have negative negative. So what do we do? So this place will have negative negative. We can simplify, right? So let's write the first thing this first thing we have at the right hand side. We have exponential x into C1 cos cosine of x minus C2 sine of x, right? Then we can factor out minus from this second one. So if factor out minus, this plus will change to minus. We have minus exponential x into C1 sine of x plus C2 cosine of x. So what do you notice from this thing, this one we got now? This quantity here is the same thing as which one? Apart from the minus sign, from here now, the second term here at the right hand side is the same thing as your original function y. Then the first term you have at the right is the same thing as what? This one we have at the right is the same thing as this quantity we have here. Let me just call it equation 2. Okay, let me call it equation 2. So this first quantity we have here is the same thing as what we got in our equation 2, and this second quantity we have here is just negative of the original function we have. So the whole thing we have at the right hand side, the first thing, this one is the same thing as y prime minus y prime minus y, and the second one is same thing as what? Negative y. So this is negative y, the second one, right? So and this will be equal to what? Y prime minus what? 2y. So this implies what? What do we have at the left hand side? We have y prime minus y at the left hand side. So what do we have at the right hand side now? Y prime minus what? 2y. So what do? We collect everything to the left hand side. So we now have y prime minus, if you bring, you now have minus y prime minus y prime plus what? 2y equal to what? 0. That's what you will now have. So I brought everything here to the left hand side. If you bring positive y prime to the left, change to negative. If you bring a negative 2y to the left, change to positive 2y. So this simply implies what? Y prime negative y prime will give you negative 2y prime. Then we'll have what? Plus 2y equal to 0. This is the required ODE we want to form. So let's look at example 4. So they ask us to form the ODE of the equation y is equals to ax raised to power 3 plus bx. So we want to form the ODE of this given equation. So we have how many arbitrary constants? A and B are arbitrary constants. So we want to form an ODE of this given equation. Clearly, you have to differentiate this equation how many times? We have to differentiate it 2 times because we have 2 arbitrary constants, and this will lead us to an ODE of what? Order 2. So let's perform the differentiation. Solution. Then what is given to us is what? Given the equation y is equals to ax raised to power 3 plus what? Bx. So right, this is what is given to us. So this implies what? What does this show? This implies before we continue, what do we have in this? What we have here is a polynomial, right? Is a polynomial. Now for other examples we treated all those examples were transcendental functions, sine, exponential, right? And cosine functions. They were transcendental functions. So we have a polynomial function here. So normally if you want to form an ODE, if you have polynomial function, if you want to form an ODE, you try to eliminate some constants. So you have to eliminate some of the arbitrary constants. So when you differentiate, you try to know if you can make one of the constants the solution to the formula, and when you differentiate again, you try to eliminate the other one and try to get the other one, and after that you will now substitute back your 2 constants which you have gotten. You substitute them back in the given equation if you are able to get the 2 constants, if you are able to make them the subject of the formula. If you are not able to make them the subject of the formula, you can still form an ODE of that. With an example, we will be able to explain that if you give an example on that. So let's look at this. We can call this given ODE equation 1. So if you differentiate this thing, we have y prime is equals to what? Differentiate ax raised to power 3. Using the power rule, you bring down the power 3, ax, remove 1 from the power, remove 1 from 3, you have 2, then plus, if you do the same thing here, differentiate bx, you get what? B, right? So with this thing now, I will make this I can make B the subject of the formula, right? So this implies that my B will be equal to, if I bring other terms to this term to the left hand side, I have that B will be equal to y prime minus 3ax raised to power 2. With this, I brought this term to the left hand side. So since it's positive, change to negative so that I can make B the solution to the formula. You can call this one equation 3. So if you differentiate again, what will you get? Come to this equation, differentiate it again, you have what? Second derivative of y. I'm differentiating this again, right? Equal to, if you differentiate 3a x raised to power 2, you bring down the power and multiply. 2 multiply 3, I'll be having 6, right? 6a x, then remove 1 from the power, remove 1 from 2, you have 1, right? X raised to power 1, which is the same thing as x. So then if you differentiate the constant b, you get what? 0. So this is what we have, and with this I can make the second constant subject to the formula, right? I can make a the subject to the formula, and this implies that my a will be equal to y prime prime divided by what? 6x. You know, if you write this thing, this 6ax, you can write it as what? As a multiplying by what? 6x, right? Which you can make a the solution of the formula by dividing both sides by what? 6x. Divide this We divide this side by 6x, divide this side by 6x. That's how we got that a is equals to y prime prime divided by 6x. So let me call this one equation 3. Okay, sorry, this one will be equation 2. Then that one will be equation 3, right? So what do? We substitute equation 2 and 3 in your equation 1. So when you have gotten your constants, I've known my a, I've known my b, right? You now substitute them in your original equation. Substitute what? Equation 2 and 3 in 1. So I'm substituting equation 2 and 3 in what? In my equation 1. See my equation 1 here. If I do that, this implies that y is equals to what? What is your a? My a, I've gotten it to be y prime prime divided by what? 6x. I'm multiplying it by what? X raised to power 3. Multiply by what? X raised to power 3, right? That's the first thing I have here in the first term. Plus, what is my b? My b is this y prime minus 3ax, right? So you have y prime minus 3ax multiplying what? 3ax multiplying, I'm putting this expression as my b here, and b is multiplying x. So this expression, which is my b, this expression, which is my b, is multiplying what? X, right? So this implies that y will be equal to, something can cancel, right? But before that, let's just write this y prime prime divided by 6x times x raised to power 3 plus, let's write this one as, this one will be y prime minus 3, but a, we have gotten it to be this, right? A is this a is so minus 3 times my a is y prime prime divided by 6x times what? Times x, all multiplied by what? X, right? So in this place I have 3 multiplying a, this is my a, right? Multiplying x, then all multiplied by what? X. So this is equal to what? This implies that my y is equal to, this can 6x, sorry, x can cancel one of the power of this x, right? The remaining x squared, isn't it? Then this x can cancel this x. This x squared can cancel this x. So what you now have is that y is equals to y prime prime divided by 6 multiplying x squared plus into y prime minus 3 y prime prime divided by what? 6, then multiplying x, right? So this will be equal to y is, which this implies that y is equal to, I can write this expression, this first one, as x squared over 6 y prime prime. Then if I open this bracket, then I will have plus, open this bracket with x, I have x y prime minus 3x y prime prime divided by what? 6. That's what you have. Then continuing the solving here, so this simply implies we can move everything, to the left hand side. If you move everything to the left hand side, you will have y, then this one will come to the left hand side, change to negative x squared over 6y prime prime, right? Then this one too, this second term will come to the left hand side, change to negative x y prime. This last term will come to the left hand side, change to positive because we have negative sign, plus 3x y prime prime over 6, right? Then nothing is remaining at your right hand side, equal to 0. So this is the required ODE. We have formed this ODE, right? And this ODE is an ODE of what? Order 2. So, and our independent variable is what? X is the independent variable.